Good morning, everyone. Let's get started for today. I guess the first thing I wanted to talk to you about is the midterm follow-up. I do want to show you here. So I have, and I want to invite you to follow along on your side as well. So I have right here the midterm follow-up instructions that you downloaded when you were doing the follow-up. So I want to invite you to open that one. And if you just launch that QMD somewhere, right? So the APA 23 midterm follow-up.qmd. So this is the same folder that you downloaded from GitHub when you were doing the follow-up. So it does have that QMD, it has a data frame, and it has a few figures that I included in that folder. So if you want to go ahead and just launch that follow-up, we're going to be working a little bit on that before we start the management zone creation today. So for me, when I double clicked on that, it basically launched or just opened up on a previous project that I already had. In your case, this may be project none, it may be a different project, but it's going to launch on a given RStudio. If you did create a project when you were doing the follow-up, you can use that. I did not, so I'm just going to double click on that and let it open on any RStudio window that I have. So please also do that. And I want to tell a little bit about some of the things that we went through in the exam and also in the follow-up. Okay, so assuming that you all have opened this, so my goal, well, I guess, taking a step back, so that if you recall from when we talked about the grades of the midterm initially, the average class grade was 79%. And after the follow-up, or 78%, and after the follow-up, that went up to 89%. So most of you were able to recover some of your grade, which that was the goal, that you could go back to your material, see where the answers to the questions were, and hopefully learn in that process. One thing I noticed is anyone that missed a coding question on the written exam and had a chance to redo a coding question, so the ones here mostly from 1 through 6, did not, or attempted but didn't get it, or didn't even attempt to do them in the midterm. And one of my goals, or the midterm follow-up, and one of my goals here was for you to learn, right? That you understand what's going on, and that you can know how to do these things moving forward. So I just, on the questions that ask you like theoretical related questions that you can go back to the material and find an answer, most of you were able to catch up on that. So I'm not going to be covering those. I do, however, want to spend a little bit of time on the coding part of it. Of course, when I gave you the midterm initially, you didn't have to code yourself, right? It was just looking at the code, the scaffolding of the code I gave you, and then deciding or trying to use that to guide your decisions of what words to fill in the blanks. On the midterm follow-up, it was more complex than that because you didn't receive any scaffolding. You have to do everything from scratch. But you still had the data and the instructions that allowed you to answer. And so given that no one really answered, I just wanted to go back to that and go and do this along with you. Okay, so if you come here to the chunk where I ask you to import the DF, you can just come to that. That's the first thing we're going to do. So the answer I was looking for here was that you would use, so I'm asking you to create an object called DF, right? So please go ahead and start typing with me. And one of the main differences as well from the follow-up compared to the midterm is that here, when you're coding, you may have to load packages that you didn't have to worry about when you were doing the on-paper version, right? So here, if you were to use so it is a CSV. So in your head, you should have been thinking read CSV. There are a couple of functions to do that. One of them is the read.csv that is in base R, which means you don't have to load any special packages. It's already part of R. However, if you wanted to use the read_CSV, that comes from package readr, which is also part of the tidyverse. So if you wanted to use the read_CSV, you would have to load it either or readr or tidyverse. I think loading tidyverse here is more helpful because it also loads ggplot2 for you and the pipe. So it kind of helps you with multiple different functions from different packages that are all part of the tidyverse. So I'm going to go ahead and load tidyverse here. So if you open and close quotation marks and you hit tab, this is a feature of a Quarto file that basically takes you to the folder of where that QMD file is, even though in my case here, it is on a completely different project. So that's a feature of Quarto, and that's why you didn't have to create a project for the midterm follow-up. Of course, like this is just a very quick example of like, we using a script to bring in data. I still encourage you to, every time you do a complex project that involves multiple data coming in, multiple outputs going out, multiple scripts, just still go ahead and create the projects. I do want you to keep that habit in mind. However, you didn't have to create one for the midterm follow-up. Give me just a sec. I'm working from home today and my dog is chewing a bone and it's maybe distracting to you. I don't know if you can hear it. All right. So if we were using the function read_CSV, we would have come here. If you just hit tab, you would already be at this level where that data frame is, right? Given the folder structure I gave you for the midterm follow-up. So you did not have to do .. in this case, right? So all you had to do was just to hit return, select df_CSV, and run it, right? And this is how this data looks like. So it has 6 rows, it has rep and rate and yield. All right, so let's go to the first actual question that I had for you relating this data set. So if I want to calculate the average yield, right? So if I'm telling you average, you should be already thinking summarize, right? Average yield for each rep. Each rep, you should be thinking group by, right? Because I want a result for each one of the rep levels. So group by in this df and assign this result to an object called df average. So how would we do this? We can get started with df, right? Add a pipe, hit return. As I do want an average for each one of the reps, I would do a group by, and this would be a group by rep. I would add a pipe. I would use a summarize, and I would ask for, so let's say, I think we can just call it whatever. I just want to call mean yield equals mean of that yield column. Right, so this is basically what I was asking you to do. And then asking you to save this result to an object called df average. So I just want to put that here, assign it, and just save the result to df average. One thing I want to tell you, and it's going to be important because we're going to be using this technique later today in class, is on the written, so on the follow-up, nobody attempts to do this. So not much to cover there. But on the written exam, some of you, so this summarize function here was a ... right? So it was a space that you could fill in the blank. Some people gave me a mutate. And I accepted that, but I do want to show you the difference. So df has 6 rows, right? If I start with df, I group by rep, and I do a mutate asking for the mean yield, the end result is still going to have the same rows, same number of rows as the incoming data set. It's just that now mean yield, every time you have, because we're grouping by rep, it's going to give us a mean for each one of the reps. And if that rep appears more than once, and it will because you're using mutate and not summarize, it will still give you that column mean yield. It's still going to calculate the average yield in this case per rep, but it's going to basically repeat that same yield value whenever you have the same level of rep. So let's say you see rep 1 here and here, the mean yield is 6 and 6. So it's okay to use group by and mutate. It will still do a summary for you. It's just not going to decrease the number of rows. It's just going to calculate that summary value and repeat it every time you have that given level of the group by variable. Okay, so on the written exam, I did accept if you gave me a mutate, because I guess I was reading back my question and I wasn't specific enough to say that you had to summarize. However, here on the midterm follow-up, I did say the final result should have 3 rows. So if you attempted to do that here and you gave me a mutate, you would have been wrong. Here I was explicitly asking for a summarize. Okay. So another good thing about that, I thought at least, about giving you the chance to code is that you could come here and try things out, right? So let's say if on paper you answer mutate and you got that right, but for some reason you needed to redo this question in the follow-up, and you gave me the same answer as you did on paper on mutate, you would have seen that your number of rows is 6, and I'm explicitly saying that I wanted 3, at least on the follow-up. So you could come here, think about it, and then realize that we also use group by and summarize as a combo, and that would get you the 3 final number of rows. So, and I just want to make a point here as well that we didn't get into a lot of detail, but I want to explain that sometimes we do want group by and summarize because we're really after that summary. We don't need that value to be appearing every time for that given level of the group by variable appears. So here I was looking for group by summarize combo. However, sometimes we do want to group by, we do want to get a summary statistics out of something, but we do want to use the group by mutate combo. So we keep the total number of rows and we just have that summarized value repeating for each level of the grouping variable. Okay, I just wanted to make that clear because we will use the group by mutate combo in the zone exercise, and so I just wanted to for you to already be aware of that. Okay, any questions about this point in specific? I don't hear anything, so I'm gonna keep going. Okay, so the next question then was asking you, what would you change in the code above to get the mean for each n rate instead, right? So here I was asking the average yield for each rep, and here I'm telling you that instead of for each rep, I want for each n rate. And I'm telling you here to write the code below and save it to an object called df average. So what you could have done, so I'm gonna do, you could have just copied this and edited, right? I'm gonna do this a little bit more separated just so you can see what I was exactly looking for. Okay, so this is the answer for the question above. If I wanted the means for each n rate instead, what some people gave me, so they got the n rate kilograms per hectare column and they changed that here on the yield. Let's run and see what happens. So if you put the grouping variable on the summarizing function, it basically is still grouping by rep and is giving me the average nitrogen rate for each rep, which is not what we want, right? I'm asking for the yield average for each nitrogen rate. So on paper, a lot of you gave me this answer and then you got it wrong. What I was really looking for was that you kept yield here because our summarizing variable is still the same. I just want to summarize by a different grouping variable, right? You really should have come here on the rep and changed rep to n rate, and this should have been the answer, right? So the mean yield per nitrogen rate was 5 and 7.7 micrograms per hectare. And if you did get confused and you put n right here, I hope that now you can understand why that wasn't the right answer. And you can, I guess fine tune your understanding of how you would do that by since now you can see the answer. So I know this point was a little confusing to some people, and I just want to again ask if anyone has any questions about this or need clarification. All right, I don't hear anything, so I'm going to continue. So here on the follow-up, I ask you to save this result to DF average 2. So I'm going to do that here. All right, so question 5, I want to plot the results from question 3, right? So I'm telling you the results from question 3. So if you gave me results or you used the columns that weren't on the data from question 4, you already started with the wrong data set. And show me the average yield value for each rep as a point. So here explicitly on the follow-up, I said as a point. On the written, I did not say as a point. So let's first answer this here, and then I'll tell you a little bit more about the written part. So if I want to, so the question 3, if we come here is DF average, right? So we could just come here, type DF average. So I'm asking you to plot for each rep the yield as a point, right? So we would go ahead, I would use ggplot. We can use the statics function at this level. And so what should go on X? Let me ask maybe someone in Tifton. What do you guys think? Ethan, what do you think?
Yeah.
I can hear now.
Yeah, that's what I was sitting there trying to remember because I missed question 5, but I'm going to be really good with the time management. I didn't have a chance to really go back and redo it at all.
No, and that's okay. That's okay. I mean, my goal here is just what we do together, right? So so DF average is what is coming into. We have these 2 columns. So I'm asking you to plot the results of this data set and show me the average yield value for each rep as a point. What do you think should go next?
I would say the mean yield would go next.
Okay, I mean, I guess we can do that. Let's do that. So mean yield. So what would go on Y?
I would assume the rep then would go on Y.
Right, we can do that. So let's do that. And then based on the question, let me ask someone else, maybe Miller. Which geom do you think we should use?
You would do like a geom line, would you?
You could. So on the written exam, if you answered geom line, I gave you okay. Like you got it right. Anyone got it right if you answered geom line. But based on this question here, so I'm asking you to show me the average yield value as a point.
Is there a geom point then that does that, or?
Yeah, that's exactly right. So we would add geom point, right? So if I just do this, run this, this is what we get. So end up with mean yield on the X, rep on the Y, and then 3 points. So if you, I don't think no one answered this on the follow-up. If you have given me this answer, I would have accepted it. I normally prefer to have our response variable, which in this case is yield, on the Y axis. I guess that's more conventional. So this is okay, and it would have been fine. I would prefer to just flip it and have rep on X and Y and mean yield on Y. So this is kind of what I was looking for here.
What was the reasoning behind that exactly? Because I reckon the way I was thinking about it was that the variable that's changing is typically what's on the X-axis, or at least that's how I was always told. So that's why I was thinking the mean yield would go on X.
Yeah. So normally what happens is if we have our response variable on the Y-axis and our explanatory variables on the X-axis, that's the most conventional way of showing things. So yeah, if you go to any paper and that's evaluating yield as a function of a treatment, you would most likely see yield on the y-axis and treatment, or in this case, not treatment, it's rep, but an explanatory variable on the x-axis. That's the most conventional way of showing it.
Thank you.
Yeah. All right, thanks guys for the help here. So this is sort of what I was looking for. On the written exam, I think you had to fill in the data set coming in. You had to fill in the column names, especially for the Y, and that required you to go back on the written part and see what were the columns available then, right? Which, if you told me, if here you told me the right date on the written, if you told me the right data set, but you came on Y and you told me yield grams per hectare, that was wrong, because we don't have that column anymore. Now that column has been summarized, and at least now I'm calling that mean yield. I don't remember what I was calling that on the written, but you needed to pay attention to what data set we're talking about, what were the columns available in that data set, and so on. Okay. Any questions about making this plot? And again, I just want to say again that on the written original midterm, I accepted that. So this was also a fill in the blanks, the geom underscore dot dot dot. If you told me point, line, bar, I accepted a few different variants, just so you know. So if we would have used line, we could have, right? So let's just try that. If I had used line, this is what I would have seen. I don't think it's the most conventional way of showing an average across rep in this case. Normally we use lines, especially if there are different ways of using lines like this. One of the common ways is if your X variable is time related, right? So you have a time series, it's common to connect the points using a line. But I still accepted this on the written if you told me line. We could have also used geom bar. I think we have to just say, so geom bar was perhaps the one that needed a little bit extra information with stat identity, but you could have also used geom bar. Okay, so let's move to the next programming question, I guess, that I had here, which was for you to replicate this plot. Of course, on paper, I gave you most of the code, and I was just looking to see if you could identify based on the data, based on the plots, what should be filled in on the code, right? So let's just go from scratch and develop this plot together. So I'm telling here to use df, right? So you should begin with df. If you started with df average, you're not gonna be able to replicate it. So let's start with df. I just want to print it so we can see it. Let me give a pipe and let's begin here. So I'm going to be asking for some help. We are starting with ggplot. I just want to call the a statics function so we can define x, y. So let's see. Sarah, based on this data in these columns, what do you think should go on x? What do you think should go on y?
Rep and yield.
Which one goes where?
For X is rep, and for Y is yield.
Perfect. All right, based on what you're seeing up here, would you like to add anything else inside the AS function at this level?
Group.
Group?
I think we should use group for rep, maybe.
We can do that. Let's try that. Okay, so anything else?
And then we should add geom box plot.
Okay, so we get outside of the ES, add a plus, and do geom box plot. Let's run that and see. Okay, it's getting there, right? So I do want to show you something here that you actually, I don't know if you played around and you knew this, but I thought was really clever what you just said. So when I was developing this question, I did not have group here, and I just want to show you what happens if you don't have group there. This is what happens. So Sarah was very clever by telling me group equals wrap. That is one way of fixing this, and I just want to tell you why we're seeing what we're seeing here. So wrap, if I just print, and please be sure to be attentive here, because this is going to happen to you for sure if you continue using R. So on DF, wrap is double, which means numerical. And every time you plot a numerical variable and you ask for a box plot, it's going to give you a box plot of the entire range of that numerical value, right? It's not going to give you separate box plots for each one of the levels, which is what we're seeing here. And that's why we're seeing a big box plot across all wraps. Sarah gave one solution, and I think that's pretty clever. It's not the one that I had initially thought of, which is creating or adding this group equals wrap, right? So if we do that and we run it, it forces the grouping based on the levels of wrap. And since we just have 3, 1, 2, 3, it creates those groupings. But that was a very clever solution. Another solution, there's another solution here that is actually the one that I thought of. And I just want to open up and see if anyone has any thoughts. Like if you were not using group equals wrap, but you still wanted one box plot per wrap, what could you have done?
We can make the rep column as a factor, not the numerical one.
Yes, that's exactly where I was going. Thanks, Sekar. That's actually the solution I did on my rubric, was to, so if we transform wrap from numerical to a factor, then it forces it to create box plots. And it's really interesting because transforming wrap into a factor, we can do that a couple of different ways. We can actually do a mutate here before getting into ggplot, right? So I can say wrap equals factor wrap. So that is one solution. So now I still have wrap 1, 2, 3, but now it is a factor and not a double anymore. And then when that gets into the ggplot, it's already doing that for us. So that was one solution. Another solution is if you don't, so this solution was at the data level before getting into ggplot. Another solution would be, I'm just going to delete here, would be to use a like on the fly change. So here you say x equals factor wrap. So you're forcing wrap to be seen as a factor inside ggplot. It's the same result. The only difference is that now on the x-axis, instead of just saying wrap, it says factor wrap, but it's the same result, right? So I guess we just saw 3 ways of doing the same thing. And this, if you would have attempted to do this part of the coding on the midterm follow-up, you would have to figure this out, which in the written part, that was not required of you, right? So just wanted to just say that. Thanks, Sarah. Thanks, Sekar. Okay, so let me ask someone else. Let's go with Umar. Umar, so I mean, looking at what we have now, right? Looking at where I want to get, what else do we need to change?
We need to add legend.
Okay, so let's do that. How
Like-
do you do that?
But I think first we need to change color.
Okay, let's do that first. How do you want to do that?
Actually, I'm not sure.
Okay, can someone help Umar? Maybe Kriti?
I would say color is equal to a box plot. That would be my guess.
Okay,
Color is
so
equal to reps.
okay, I like where you're going. So where would that go?
That would go in geom box plot.
Right here?
Yeah.
Okay, let's try that. So color equals rep. That's what you said, right?
Yeah.
So if we do this, it gives us an error. It says I mean, it's not very useful, I guess, the error message, but it's given us an error.
Oh,
And
I
even
get
though,
it. So we won't do it in box plot. We will go it in the next line where we will give it scale color.
okay, so let me just tell you that that's not what's going on.
All right. I'm
So
not sure. I'm sorry.
no,
I
no
think
worries.
inside
That's
Inside aesthetics, we'll add color for rep.
yes, you got it, Kriti. Thanks. Yeah, so if we add the AES here, that should work a little bit better. The only thing is that right now it's still seeing rep as, so because I changed rep to a factor at this level, but I have to kind of do that for everything that I refer to rep if I want that to have an effect. So I would have to say here factor rep as well. I mean, as one of the solutions, right? We talked about the other solutions already, but that's exactly right. So what happens here, if you always think that if you are mapping something on this plot according to the levels of a variable, that sentence should trigger you to think it should go inside AES. If it's going outside of AES, you can still change it, but not according to a variable, right? So let's say if I wanted, I'm just gonna do a new geombox plot here just to show you. If I wanted to change the color of all box plots to blue, right? I could say color equals blue, and it will accept that because blue is not a variable. It is just a color value, right? However, if I want to change them individually to different colors, and those colors are changing according to a variable, then you never say color equals blue, you say color equals variable name, and that variable should be in the data set that you're bringing in, and that should be inside of a statics function, as we just did here. Awesome. Okay, so what else do we need to change here to make this match this? Anis, what do you think?
We need to change the labels using labs.
Okay, I like it.
Yux
Which
is equal
labels?
to Yux
Say
is
that
equal
again.
to Yux is equal to quotation and then replicate,
Okay,
and then Y is equal to yield and then quotation yield. Yeah.
okay. All right, we're getting there. So we changed that, we changed that. We still have, so in the case I gave you, there's still wrap there, and here is saying factor wrap. How could we change this label?
Which label? Legend.
This one, the
Oh.
factor wrap, the legend label.
Legend. I think we use legend.
Title.
Legend, title. So I mean, there may be a couple ways to change it. I want to show you how to use labs to change it. So because the title of this legend is based on the color that we assign based on factor wrap, I could come here and say color equals, and then, I mean, if I want to replicate this, I would say equals rep, right? However, if I wanted to make this more professional, I could say replicate, which is not what I was asking. I just want to show you that it doesn't have to be the variable name. This text here can be whatever. It's just that this is mapping back to whatever you change up here. If we had changed the fill here of the box plot, which is also something we can change, then here on the labs, I should have said fill instead, right? Okay, so let me just go back to color on the box plot aesthetics and also color on the labs, and keep just the word wrap to be exactly as what we're building up.
Dr. Masters, can we do theme and then legend.title and set the title name? Can we
Yeah,
do that?
I think we can. Yeah, normally I use theme just to change, like, to say if I either want or don't want to have that title, or maybe to change the size of the title to make it bold. things like that. I never use theme to change the actual text label of the title, but maybe there is a way. Yeah, it's possible. Okay, so we have one more thing to change here before we wrap up this exercise. What are we missing to make our plot look exactly like that? Let me see. I don't know how easy it is for Athens students to answer. I know that you're on the computer there, but let's see. Maybe I'll call Peter, since he may be in Athens in person, but he's also on Zoom, so maybe easier for him. Peter, what do you think we're missing here to make our plot as is now to look like the plot that we're looking for? Okay, maybe Peter is not there. So I'm gonna call those that I can see on my screen. Matt, what do you think? So this is what we have now. This is what we're trying to reverse engineer. Perhaps let me ask you this. What do you think is the difference between them?
Can do from here. Can do also. You can also do from here. Oh, it can.
Oh, I can hear Athens now.
Scale color.
Say that again.
Scale color.
Yes. Okay, so we add here a plus, we say scale, color, and then what would you propose?
I don't know how to pronounce it.
Viridis? Yeah, I think that would be a good solution. So if I just say Viridis, it says discrete value supplied to continuous scale. We can just go ahead and use the Viridis D for discrete, and that gets us there, right? So on the written exam, the color here was a fill in the blank. Some of you said fill here. And that, for this case, it would not have worked, right? If I change the fill, it has no effect because on the AES, I'm specifying color. So if I want to change the color scale, I need to use color here. Did you say something, Peter?
No, I was testing my computer.
Oh, okay. I think you are in person in Athens. Yeah. No, yeah, no worries. You can just mute yourself and yeah, okay. All right, so yeah, this is basically the answer that I was looking for. This one was a little bit more, I guess a little bit more difficult than the previous ones, but you can see still that like the way of thinking of how you would develop this are things that we've been doing a lot in class, and I am taking some time today to spend on this, and I hope that you're following along, because this, just like the way you would approach this is the same for every problem, right? So I really wanted to take the time and walk through each step here so you do understand how you could have approached this problem to solve it, and also how you can approach similar problems in the final project, in your research, and in your future endeavors if you continue using R. Okay, so this is the extent I wanted to explore today for the midterm follow-up. One of my hopes is that you would have, like, if you have the chance to actually code, you can type whatever you think is the answer and run it. And if it doesn't work, then you can try to see what's going on and maybe learn from that, right? Like, so trial and error, which is not something you had the option to on the written exam. So if you in the written you said fill here, there was no way you had to check if that would work. Of course, with the code, you do have the chance of saying something or writing something, running, and see if that gives you what you're looking for. So I do encourage you to do that when you have the chance. Like if you're doing something in coding, don't be afraid to make mistakes. That's how we learn. Make mistakes and use them to learn how to get things right. Okay, that was the extent I had for this. So I'm stopping to talk about the midterm and the midterm follow-up here. I do want to open up in case anyone has any questions, either about what we saw here as far as the answers on the coding questions, but also if you had other questions about the midterm. This would be a good stopping point to talk about that. All right, I don't hear anything. I just want to say that your grades already are reflecting the follow-up grade. If you do want to see your exam, you would have to set up an appointment with me. I'm not going to be turning back to you your exams, but you're free to check them out if you wish. You just need to set up an appointment with me. All right, so let's move on to our zone management creation exercise. I'm going to close out of, or at least maybe just close this script because I'm just going to close this altogether. So I did share a partial script with you yesterday, or last night for this exercise. It is on our GitHub repo. So go ahead and download that again to your computer, the entire repo. I just want to show you here where that is on my side. I mean, you can go ahead and download it, but it's as you would expect, it is in that 04 class code folder, and the script is called 0329 management zone partial, QMD, right? So I'm showing you the partial script for that. We're going to develop that now in class. And I do want to show you my folder structure so you can see. I do want you to, once you download that from GitHub, create at the main folder of the course on your computer, create a project called 08 management zone. Inside of that project, go ahead and create a code, data, and output folders. Move that code into the code folder, and then create a project at this level, right? So I just want to, I guess if I show you this screen here, that's enough for you to see the name of the folder that I'm asking you to create as the project main folder, and then code, data, output. Move that code folder into the code, or the code file into the code folder, and then we'll get started. I will just give a moment here for you all to be able to do that. All right, I'm gonna get started. If you're still working on downloading the GitHub repo, creating on your computer the folder and subfolders in the RStudio project, and then moving that code into the code folder, you can finish doing that. I don't think you're gonna have issues with that since we've done this a lot of times already. But if anyone, for some reason, is not able to do this, let me know and we can stop for a moment. Okay, so if you just created that RStudio project, it probably launched an RStudio window for you. Again, you can always check if you're in the right project by checking the name of the project on the top right corner. So it should be showing 0A management zone if that's how you name your folder for this project. Again, if whatever view you're seeing here in your files, if that's not where you think you should be, you can always click on that R blue button to take you to the home of the project. And then you can navigate at that point to the code folder and then launch your partial script. And then if you just come to the top of it, let's just get started here. Okay, so I guess pretty much everything we've been doing in this course using R up until this point was leading up to this exercise, right? So if you think of it, all the layers that we use, the EO data layers, the processing we did there, the like EO data cleaning with the different filters, then interpolation and getting all that to the same grid cell size, and then bringing in terrain variables, bringing in SOIC data, and interpolating them as well, and exporting, and all that we did is to now bring those layers back in and create management zones, and that then we're going to validate them with EO data and see what we learn from that. So with today's, or I guess maybe not only today's, but the objectives of this exercise here are going to be to first import the data layers that we already have processed and have already merged. So if you remember on the previous exercise, we already brought all those layers and merged into one object. So already did that. I just want to bring in that merge object already. Then we're going to use an algorithm called k-means that is a clustering algorithm. So this algorithm here basically tries to look for groups in a given data set. That data does not need to be geospatial. In our case, the data is geospatial. The algorithm doesn't care. It's going to try to look for groupings based on the variable values and not necessarily on their spatial distribution. Then after we create our clusters, which in our case relate back to management zones, we're going to assess how the variables that created those zones are affecting those zones. So how are they being characterized? And then validate those zones with the EO data, both the spatial temporal stability areas and then also the individual EO data. So that's the goal for today, or for this exercise. I do want to, so we're going to be using a few packages here that we have not used before. I left you the code up there so you can just remove the hashtag, run the first one, install it. Do not use the play button here on the chunk, as that will run the entire chunk, which is not what we want at this point. We just want to install that one first. Once you install it, so if you comment it off, have your cursor anywhere in that row, and just push Command Return on a Mac, or I guess Control Enter on the PC, that will run just that line of code, and that's what I want you to do at this point. And then you comment off that one, go to the next one, and so on until you install all three. At the end, make sure you have added the hashtag in front of all the installed packages. As always, we only install a package once, and then we load it on our sessions every single time. So you can go ahead and comment off the install packages functions, and then if you do have them comment off, then feel free to just run the chunk, to play the chunk. And you should have all the other packages already. If you don't have, if it gives you an error saying package X couldn't be found, you already know how to install it, so you can fix that on your side. Okay, so the first thing that we're going to be doing here is just importing this data set that we have already merged in a previous exercise. So it is a GeoJSON file, right? So you should be thinking that we're going to use a read_sf. And if you recall, this is in a different project, right? And we already talked a little bit about this, of why I don't like creating a file on one project and then copying that file and pasting in the current project. I think that creates room for different versions if you, for some reason, have to go back and change the original file. So instead of doing that, we're gonna navigate to that project's data folder and get it straight from there. So if we have our quotation marks, if we hit tab, we are inside of the code folder, right? Which for me shows me two options. For you, it may have already auto-completed with the partial code since that was the only one you had there. As you know, we want to get outside the code folder. So if it did fill already for you the the script, just delete it. Just make sure you go back to just having quotation marks. So to get outside of that, we're going to do .. Now we are at the main level of the current project, but we want to get outside of it so we can see the previous projects. So .. again. Now I am at the main folder of the course on my side. The all-v object is in the 07 stability validation project. So we select that one. If we hit tab now, we can see the main folder of that project. We want to go inside the data folder. And if we hit tab now, it should already autocomplete for you the allv.geojson, as that is the only file that is in that folder. If you run this and you print it, so we see that we have those 4,032 rows, and that's again because of the number of cells on the grid. This is that number of cells. We do have the standardized yield for, so this data set here has 14 columns, right? So we have the standardized yield for the 3 years that we analyzed. We have the mean pixel, which is just like the standardized yield across all those 3 years. So the mean pixel is just the average of these three values. We have the standard deviation of those pixels, the coefficient of variation, which if you recall, mean pixel and CV pixel are what we use to create the ST class classifications, which we also have in this data set. Then if you go to the side here, we have elevation, slope, aspect, full direction, ECA, shallow and deep, and then finally the geometry. So this is what you should be seeing. You should have been able to import a data set that has 4,032 rows and 14 columns. Excuse me. If you were not able to do that, then you, at some point, you're going to run into issues. Maybe not very soon, but at some point in this exercise. So let me know if you have issues getting the same data set. Okay, if we come to the next chunk here, we're also going to be needing the boundary at some point. So I'm already bringing in the boundary and doing the same idea of going to the project where we created that boundary, which was the 04 yield monitor. And then this boundary, when we read it in, it is WGS. So I'm already right here connecting a pipe and transforming that to UTM zone 16 north. So just run that. If we print it, we can check that it is the proper CRS. I guess I did not check above, but this should also be proper CRS already. So it is, we don't have to transform it to LV. And then as always, we always check a summary. The summary just, again, every time that you're looking at the summary and you know your variables, you just want to make sure that your minimum and maximum make sense, right? So if I have a maximum standardized yield of 1,000%, maybe that's a typo. You have to go back and see what happened. But the summary is just a quick way for you to see that, right? Make sure that the range of values make sense for different columns. And also make sure that if you do have an ACE, that you at least know why you have an ACE. If you remember, we only have an ACE here on slope, aspect, and full direction. We already talked about why that is the case. So it makes sense that we have them here still. Okay. So here's what, so I have a lot of text here that I do want you, I'm going to be talking about it, but as you have already noticed, if I have text explaining something in my code, it is fair game for me to ask that in a quiz, in an assignment, and especially in an exam. We're not going to have any more exams, but quiz and assignments are fair game. So if I do have something written, take that as studying material as well. So k-means, it is a very popular clustering algorithm. and it is unsupervised. The reason for that, so there are basically two classes when we're talking about clustering algorithms. One is supervised and the other one is unsupervised. On a supervised algorithm, you give the labels that you're looking for. So you give the group names. So let's say if I already had management zones here, I already had a column in my data saying management zone 1, 2, 3. And now I wanted to understand what are the drivers of those management zones. I would use a supervised classification algorithm or clustering algorithm, and I would give the labels or the name of the zones to that algorithm and ask it to find what other variables are impacting those zones. In this case, in the case of k-means, it is unsupervised, meaning that we do not have the labels yet. The algorithm itself is going to help us to find groups that will give those labels based on. So that's why it's called unsupervised, because we do not provide the algorithm with the labels of the groups that we're looking for. We let the algorithm itself search for those groups and give us those labels back as a result. Okay, so it is called, the reason why it's called k-means is, one of the reasons, I guess, is because it looks for groups, and the number of groups is referred to k. So let's say if we have 10 management zones out of this exercise, then our k value equals to 10. So that's the k refers to the name of groups that you're looking for, or that the algorithm is looking for. And so that's just a little bit of understanding of the name. Okay, so I do want to give you some understanding of how this algorithm works. So you can really or better understand what's going on behind the scenes. So this is a data set here. It's not our data set, but it is a data set that I'm just bringing in for example. So we have here only 2 dimensions, right? So we have dimension X and dimension Y, or 1 and 2 as it is named here. If we were to give k-means this data set here and tell it to look for how many groups there is in this data set, k-means would do that for us. And I guess before we move any longer in this explanation, I just want to ask someone, if you were given this data, what do you think, from just visually inspecting, what do you think would be k? How many groups do you think there is in this data? Maybe let me ask. Oh, yeah, go ahead.
3.
Yes, 3, right? I mean, I think that's pretty, thanks, Anish. I think that's pretty clear, right? I mean, we have 3 groups here, and you can imagine, here these variables on the X and Y don't make sense, but imagine you had, let's say, your X-axis would be, I don't know, slope, and your Y-axis would be EC shallow, for example, right? 2 variables that you're given the algorithm, we can already visually assess that we have 3 groups. So it's not like k-means is having a hard time finding those 3 groups, because if we visually can already see it, it's going to be very easy for k-means to find that for us. So it's always, if your data, so let's say in this case here, yes.
I ran that chunk to pull up that graph right there, and nothing happened. Like, it didn't come up with an error; it just nothing showed up. And I've been following along so far, and I don't. There's no errors or anything.
Yeah, I'm not sure why that is. Did that happen for? Did that happen for other people?
Yes, I can't see anything either.
Okay.
Yeah, I can't see anything either.
Okay.
Maybe it's taking
Awesome.
longer. It's processing. Okay,
so let's do this. I will, I mean, for now, I guess you can look at my screen. I will share these figures with you. So this is pulling from my from one of my websites, and maybe there's something going on there. And for some reason, it works on my side, but yeah, I guess one of the things that maybe I didn't. Let's see if we loaded that. We didn't load.
Professor,
So
if I
let's
open
try.
the console, you told me last time that if I have a greater than sign there, it means it's trying to run it. and it's in the
Yes.
process, and that's what it shows on the console. It shows a greater than sign.
Okay, well, let's address that then, because that's going to be important for you. So what Umar was referring to is every time you run a chunk or run code in R and it is still running, so it hasn't finished running. So, well, let me say the other way around. So if I run a chunk and it goes through, it runs, and then it finished running and the console is ready for the next code to come, you do see the greater than sign here. So this having the greater than sign here means that the console is in idle and is waiting for the next command. If you do not see the greater than sign on your console here, it means that it's still running or it is waiting for another command. So let's say if you do like if you use a pipe, for example, and you say, I don't know, you say something and your last line of code ended on a pipe, the console will have a plus instead because it understands the pipe at the end and is waiting for the next thing to come. In this case, it was not a pipe, it was not a plus. What is, if you don't see the greater than here, is because maybe you're having issues running this and it's just taking longer to run for some reason. And if you're not seeing that here, the greater than sign here, it means that your console is busy, which I was not expecting. On my side, it runs all right. So if your console is busy, there's probably, so if you expand this window here, you will be able to see a stop sign somewhere here. You can push that to kind of like force it to stop doing what's doing so it can go back to idle. And that's what we want to do, because if it is busy, you're not going to be able to run any code until it goes back to idle. And I'm not sure why it's taking long to run this on your side. I can troubleshoot that later. But for now, I would say just if you can stop the console from running that command, that's what we would like to do. So for the time being, don't worry about running the figure chunks. I will fix that and give you this result so you can study in the future.
Hey, Dr. Besto,
Yes.
I don't have that stop sign and I've got the arrow at the bottom. I think mine is idle right now.
Yeah, mine's idle down too, and it's still not running those mid-or include graphics. Chunks.
The same.
Yeah, I'm not sure why that is. So let's try. So what I'm gonna ask you is, so this include graphics here relies on the package knitr. I don't remember if that comes already installed or if we have already installed. Maybe that's what's going on. So on your side, if it already went to idle, just try to do a install packages, open and close quotation marks, and then knitr or knitr. Try to do that and install that package. And if it tells you like that you're using that package, that is trying to, restart R. If you need to restart R, you can go ahead and do that. It should be pretty fast. Let me try on my side. Yeah. Okay, so it's saying, do you want to restart R? Sure, we can restart R. So restarting R, I'm gonna say no this time around. Okay, so it went through and installed. So at this point, so on my side, I just showed you, like I just went through the process of installing knitr. I said yes the first time it prompted me to restart R, and I said no the second time, and it went through. And now if we come to the chunk that we were, I guess the first thing would be to run all above first, because R restarted. So maybe in my case, it seems like my objects are in my environment, but if they're not in yours, you can just go ahead and run all above.
Dr. Bastos, what's the function of tidyr? Package
So
tidyr.
the package tidyr,
Yes.
tidyr is one of the data wrangling packages. So the two main data wrangling packages are tidyr and dplyr. Is that giving you an issue?
Yes, I couldn't load that package
Right.
at all.
Right, that's the same case for me as well. When I try to load the tidyr or tidyverse library, it shows me a error like VCTRS version is not matching. We need the upgraded version like that.
Okay. Huh. All
And
right.
then same
Fun stuff.
same with the library zzpub_r.
Yeah, that's correct.
Can you say that again?
And same is the case with library, the last library that we load, zzpub_r.
Dr. Bastos, I also got the same error. I just installed the VCTR packages and then my TDIR works. So may you have to install the VCTR package again.
So which package did you say that we have to that you reinstalled them in there?
The error which is giving because it is VCTIR package. Because it is outdated, so they say it needs updated version.
Okay, so you're saying, so can you spell the package name? I'm not getting.
I think it's name, yeah.
Oh,
but he has
okay, yes. Awesome. Yeah, maybe that's a new dependency that came up, but okay. So basically what Arminder and Sikar are saying is that if you do an install.packages, open and close quotation marks, and then do VCTRS, which I guess stands for vectors, you can try that. That seemed to be the solution for Arminder.
It's still not working, Dr. Masters.
In the warning, it says that VCTR yes, O.5.1 is already loaded, but greater than or equals to O.5.2 is required. So
I think you have to uninstall, then install the US.
Oh, Peter, we have a Nico coming from your side. Maybe, let's see. Maybe if you try to go to the podium, unfortunately, I don't know if, well, maybe if you just turn off your mic on your computer, I think we should be able to hear you. Okay, so Peter is saying uninstall the previous version, then install the new one. Are you talking about the VCTRS package, Peter? Yes, okay. So what Peter is saying is to uninstall, and I actually don't know if I know how to do that.
Sorry, Professor, I think we need to reinstall tidyr because it says tidyr 1.2.1 is loaded, but greater than 1.3 is required for ggpub_r.
Okay, so ggpub_r is what's giving us.
Yeah, for me, it's
problem.
giving error for ggpub_r, and that's what it says on the bottom.
Okay. Okay, so Omar, you said that we may have to reinstall tidyr.
Yeah, the newer version of which should be greater than 1.3.
Okay, there we go. So Peter actually provided the code. Thanks, Peter, to remove the package. Which is this one here. So it is in the chat, but it is remove.packages and then vectors. Okay, so Peter, you said that you removed this and then you reinstall it. So you did like.
Yeah, that will work. Yeah, that works for me.
Okay. Yeah, so if anyone else is having this issue, if you want to try this couple of commands here to first remove that package and then install it, please go ahead and try that and let me know how it goes. I guess perhaps I'll ask this way. Is anyone still having issues with this? Because then we can.
Now we don't have issues with loading packages, any packages, but still NetR doesn't work, so.
Okay. Yeah, I don't know what's going on there, and I guess I wasn't anticipating all these issues. So I guess what I'm gonna do, what I propose that we do now is I'm just gonna run those chunks on my side, and then at least you can see on my side what that looks like, and then I'll work on fixing this after class and get you the code to import those images. Well, you know what? Let me actually try. Let me propose something else. Let me see if this would work.
If we try to go to that web link, it says page not found, Dr. Bastos. I think, is that the problem?
Okay, so the website may be the problem. Okay. Yeah, that makes sense. I thought it was related to the functions. Huh. So on my side, I can see it. I can see the figure on my side. That is just really odd. Okay, well, I guess we can, let me try one more thing here. Okay, so let me ask you all to try this on your side. So if you go outside of the chunk, right? So on the space where you can add comments, add a exclamation point, open and close brackets, and leave within the brackets empty. Open and close quote or parentheses, and then from the chunk below, copy that address without the quotation marks, and just paste that address inside of the parentheses. So this is what I'm asking you to do. Try to do that and see if that works.
Could you repeat that again, Dr. Bastos, please?
Yeah, so basically, I'm asking you to do what I have highlighted here in the code, which is just a way to bring images into a markdown, into a Quarto file. So let me just redo that again. So the way to do that is we start with an exclamation point. So this has to be outside of the chunk, right? So NetR was inside the chunk. Now I want you to come outside of the chunk, of any chunk, and just add exclamation point, open and close brackets, open and close quotation marks. Sorry, not quotation marks, parentheses. So brackets, parentheses, and then copy that address that is on the chunk below, but leave the quotation marks behind, and paste that address on the in between the parentheses.
That worked for me. Thank you.
Okay, so maybe let's do that instead, because we have a handful of NetR include graphics coming down that on my side they're working. I don't know what's causing it to not work on everyone else's side, but a quick fix to that is just to use a different way of bringing an image. It may not be a very large image at this point, and we can fix that in the future, but at least for the time being, let's just go with this approach. Okay. Was everyone else that was having, is anyone else still having issues even with this new approach?
It's working.
Highlighting and click control enter.
Yes, I'm having errors.
I'm not running.
Do you have an error, Zumar?
Yeah, it says error, sorry, error unexpected, and then the large bracket as we refer to it.
Mm-hmm. So and you did exactly as I have here, exclamation point, open and
Yeah.
closing brackets, open and closing parentheses, and then the address without quotation marks?
Yep.
Okay. Well, we can look into that after class. I guess at least during class, you're going to be able to see my code and follow the explanation that way. But we can address that later. Yeah,
Right.
sorry everyone for this. I was not expecting for this to be an issue, but we definitely want to make sure you can see it. So on my side, I'm going to go ahead and leave the knit R, but on your side, if you do want to bring that, you can use this approach here using the exclamation point, open and closing brackets, open and closing parentheses, and bring in the address that is on that chunk in here. If you want to go ahead on your side and delete the chunks that have the knit R, because it seems like that was making your consoles to freeze, you can go ahead and delete that. I'm going to leave on my side because on mine they work, but on your side, make sure you delete so you don't get stuck. Okay, so I guess returning to our k-means explanation. So again, k-means is a very popular clustering algorithm. And all right, a few more. Okay, a clustering algorithm that identifies groupings, right? In this case here that I was mentioning to you, we only provided k-means with two variables, right? And you can think of each variable being a dimension. So k-means only has two dimensions to look for groups, which in this case is pretty straightforward. We can even by ourselves kind of identify groups here, right? So we have one group here, another group here. Pretty straightforward. However, sometimes it's not easy for us to visually find those groups. And the reason is that, especially when you start having multiple variables, right? So now imagine that I have 10 variables. First, how can I even visually see 10 variables in one plot? I don't think there is a good way of doing that. I mean, if you're really, really creative and resourceful, you may, using ggplots, using color, fill, transparency, size, you may be able to include, I don't know, 4 or 5 variables in a plot where one is X, one is Y, another one is color, another one is size, another one is transparency. You can do that, right? We can have maybe 5 variables depicted in a plot. But it starts becoming really complex for our brains to see groupings when we're looking at so many variables, so many dimensions. So in that case, a clustering algorithm like k-means can really, really be helpful because you use mathematics to find those groups, not visually assessment like we do, of course. And it's just, it has an easier way of identifying groups when you have multiple variables. And in other words, multiple dimensions. Okay, so let's talk about how would k-means work? How does it work in general? And how would it work for this data set here? We come to this next chunk. I'm gonna print it on my side so we can see it. If you, again, I guess on your side, if you were having issues with the knit R before, you can again use exclamation point, open and close brackets, open and close parentheses, just copy and paste the address on the chunk below with leaving the quotation marks behind. Let's see if that works. Okay, that didn't work this time around. So, okay, here you go. Maybe it was loading. So it did work, it did import it. And then go ahead and delete this chunk here that you have the knit R if that was giving you issues. But what I really want to show you is just so we can see this plot here together. So the way the k-means work is, let's say one thing that we have to tell k-means is what is the number of groups we wanted to look for in the data, right? So k-means needs that information from us. So if I look previously at this graph, and visually I can tell I have a good hint that there are 3 groups in this data, I go on the k-means algorithm and I say, hey, look at all this data, including terrain and EC data, and look for 3 groups, because I'm pretty sure there are 3 groups here. So in that case, what k-means does is it randomly selects 3 data points in your data and set them as the initial center of the groups. So what you can see here is this example. So that's the first step of the k-means does, is randomly select k number of observations and set them as the center of the groups, right? So in this case here, that observation was set at the center, this was set at the center, and this was set at the center. This is a random process. And because of that, it may be that your initial guess of which 3 observations to choose may be a bad guess, which in this case here, if we were to stop here and not move forward with the analysis, this would have been a terrible clustering algorithm, because we can clearly see that everything that's in green, so everything on this area is being considered one group, everything in purple, so here is another one, and everything in red is a 3rd group, which is not a very, very good grouping for this data, right? We can clearly see that. However, k-means does not stop there. This is just the first step. Now, once k-means come up with the initial seeds of the group centers, it then calculates the distance of all data points in the data to each one of those 3 group centers, and assigns each one of the data points a cluster membership based on that distance. So in this case, what we're seeing here is everywhere that we have, so it basically does a distance between this point and that center, this point and that center, this point and that center, and whichever center is the closest to this point becomes the membership of that point. So we see green here because the distance between this point and the green center is the smallest one for this point compared to the other centers. And it does that for all data points. Once it does that first step of randomly selecting k seeds, calculating the distance of all points to those seeds, and assigning a membership initially, then it uses the average of all the data points within that first membership. So let's say it takes the average of all these green points here and uses that as the new center of that green cluster. And it does the same for the purple. So it takes now that it I know this can be a little bit confusing, so I do want to repeat myself multiple times. First step, randomly choosing actual observations in the data as the centers of the k groups that you specified. It does that, calculates the distance of all points to each of the centers, and assigns a membership to each one of the points, all the points in the data, based on the closest center. Once it does that, which is what we see here, then it calculates a new center average, basically averaging the values of all data points that in the first shot ended up in that center. So as it does that, as it calculates the new average of the new center of the cluster here, now the new center of the cluster is not an observation anymore. It could be, but it doesn't have to be an observation observed in the data anymore. It's just going to be an average value, right? So if you imagine, like if we were to take the average of all the green points here, maybe the new center would be somewhere here, which is not a data point observed, right? And it basically calculates that new average in the next iteration, recalculates the distance of all points to that new average center point for each one of the points of the clusters, and then reassigns membership. And it does that multiple times. So it recalculates the average, calculate the distance, reassign membership, and then the next step, recalculate the average, reassign membership, recalculate the average and reassign membership until the centers don't change anymore, until they don't move anymore in space. I know I just use words to describe this, which is it may be difficult to grasp that concept, but I do want to show you at least on my side, I know it works, a GIF. And really, if you just take this website here and you like paste that on your browser, you should be able to see it. But I want to show you an animation of that happening for this data set. So we have steps up here. So it starts on step 0 and it goes to step 12. It's kind of fast, but it's doing that by, on the first step is finding, so step 1, it finds observations on the data randomly, calculates the distance to all points, assign membership. On step 2, uses that current membership to recalculate the mean center of the clusters, reassign membership, and continues doing that until the center of the groups don't change anymore, until the mean center of the groups don't change anymore. And you can kind of see if you're tracking the X's here represent the center of the groups. So they start off really away from the center of the groups that we think exist. And as the iteration continues, you see that the green center, which started up here initially, starts moving down. The purple center starts moving up. The red center starts moving up as well. And they kind of align with what we visually thought, or where we visually thought were the center of the groups. And then whenever that mean doesn't change anymore, because it found an optimum, right? It found an optimal solution that the center means are not changing anymore after each iteration, then it assumes that it found a solution and then it stops there. This is how k-means work, at least like the theory behind it. And I know that, explaining words can be a little bit complicated. I hope that this animation here gave you a little bit a better understanding of what's going on behind the scenes. And I do want to open up if anyone has any questions or need clarification on this. Okay, I don't hear anything. We're going to basically be applying this algorithm, k-means algorithm, to our data. And even though in our case, we're not going to be able to just make a nice plot with X and Y and look at the clusters like we're doing here, because we have more variables than just 2, and it becomes difficult to visualize it. But we are creating clusters that translate into the space, into a map that has geolocation, right? So we're at least going to be able to see our clusters in space and how that looks like. Okay, so I do want to point out a few things here. So if you're thinking of using k-means or really other supervised or unsupervised clustering algorithms that you may learn elsewhere, I do want to point out some properties of k-means so you become aware. So we can use k-means to create clusters. And again, cluster is the general term, but if you think of it, management zones are basically clusters, right? So in our world of precision ag, clusters we can think of that as management zones. Again, it is unsupervised analysis because it has no outcome or response variable or y on a formula y given x, right? So we're just giving the x's to k-means. We're not giving the y. So we're not saying, this is my response variable, explain it. We're saying, here's a whole bunch of explanatory variables, find groupings between them or among them. We can also think of x's in a formula as predictors, right? So I guess another way of saying that is that k-means only takes predictors, meaning that it's basically just your explanatory variables or predictors in your formula x or y given x, you're just giving x's to it. And one of the perhaps features or limitations of k-means is that it only takes numerical variables. So if we have categorical variables like treatment, or maybe rep, or maybe in our case, flow direction could be considered numerical, but we know that at least from an interpretation standpoint, it really should not be numerical because 1 is not less than 2. It's just a different direction. It could have been named ABC or maybe north, south. It would still have the same meaning. So I guess we can say goodbye to flow direction in this analysis at least. Okay, so K-means is a very popular clustering algorithm and is being used across very different disciplines. And it is very useful, however, it does have shortcomings. So K-means is very useful to find clusters that are circular, right? So that you kind of have like a spherical shape to a cluster. Not necessarily in a spatial context. It doesn't have to be circular in space. It's just circular when you plot X and Y. And X and Y, I mean, if you think of X and Y, right, that's the easiest way to think of it. But it could be, you know, multiple dimensions, not just 2 in this case. However, it can fail quite badly to find clusters if you have odd shapes. So if you think of like in this plot here, if our clusters, they're pretty circular in this case, but imagine that they were flat. You have like flat clusters. K-means we have a hard time finding those clusters because of the way it works behind the scenes. Or if you have outliers. So if you have outliers, K-means also has some trouble finding the clusters for you or making sure that it finds clusters that make sense. I do want to bring here an image from a paper that is really helpful to kind of understand that. So here, each column is a different clustering algorithm. K-means is the first column. And then we see that so each row in this table is a different data set that has a different structure of grouping in the data, okay? So think of it that like this is X and Y. So X and Y, you're plotting those clusters in a X and Y dimension, and you're asking different columns here being different algorithms to find those clusters. So for example, we see that if we look at the first column here that is just looking at K-means, K-means was quite well to find the 3 clusters that I'm highlighting here because they're circular, they don't have a lot of outliers, pretty easy to find those clusters. It did an okay job in finding these three clusters here. Perhaps some of these orange observations should have been green. It failed poorly on other cases. So let's say on this first data set here that we have circular clusters, right? The way that K-means split that data was going through right half of it. So if you think of it, the orange cluster center is probably around here, the blue is probably around here. But this is not the best way to create clusters for this data, right? If you imagine the inner circle should probably be, the entire inner circle should probably be one cluster, and the entire outer circle should probably be another cluster, which is actually the solution that was found by this other algorithm called spectral clustering, that was able to find the inner one as one cluster, the other one as another cluster. And K-means failed in that situation. Other examples here where K-means failed was the second row here. So this data set where the clusters kind of like do this shape. You see that K-means also fail badly, and other algorithms were able to find those clusters in a better way, right? So again, spectral clustering, DB-scan are some other options also commonly used. So I guess I'm showing you this. You don't have to really know this. I don't expect you to know anything else about these other algorithms. My main goal showing you this picture or this figure here is that K-means is a good clustering algorithm, but it has shortcomings. And we kind of have to keep that in the back of our heads when creating clusters as well, because these data sets I'm showing you, they're all 2-dimensional, right? There's X and Y. So it's easy for you to plot, see the clustering results, and see if it makes sense. However, normally we use clustering algorithms with multiple variables, multiple dimensions that we cannot visually assess the quality of that. So knowing the shortcomings before selecting a clustering algorithm is actually better information to have, and then selecting the proper algorithm for the data that you may have, rather than simply assuming it's going to work well in all cases. So just that's the point I wanted to make out of this. K-means is useful. It has shortcomings. Okay. So I do have some text here just saying that one way that we could try to see if K-means is actually a good algorithm for a given data is to use some machine learning techniques like splitting data, training and validating test splits, and then selecting a model that has the best predictive performance of clusters. We're not going to be talking about that in this class. That is not the goal of this class. We will talk about this in my data science class if you're interested in that topic next spring. But for now, I just wanted to mention that one way that we could address to see if K-means is doing a good job, or any other algorithm for that matter, is doing some machine learning, using some machine learning techniques, which again, we're not doing here. All right, so that was a lot of conversation, I guess, somewhat unusual for my class. We normally code more than talk, but I hope that this was able to give you some intuition on how K-means is working and when K-means is a good algorithm and when, in some conditions, of when it's not a good algorithm. All right, so let's come back to our coding and let's actually start running K-means for our data set here. So if you come on the next chunk, so one of the things about K-means, and we talked a little bit about this, is first, it can only contain numerical variables. Number two, it does not handle NAs. So if we have one NA in one column, that's going to cause issues when K-means is running. So we do have to remove NAs before giving this data set to a K-means algorithm. So on this next chunk here, if you want to join me now in coding, that's what we're going to do. We're going to prepare this data to be run in the K-means algorithm. So the object that we started off was all_v. I want to do some changes to it and save that to an object called all_v_n to mean numerical. If I just print all v here, what I do want to keep here is, so first I want to keep the variables. Well, wait, let me take one step back. First thing I want to do here is drop an A, right? So we cannot have NAs when we're running K-means. So the first thing here I want to do is just come add a pipe and use a function called drop an A. So right now our data all v has 4,032 rows. If we drop an A, if you run that and then you print it, we end up with, wait, something's wrong. Let me inspect this. It should be less rows because we have NAs in some of these columns.
If you didn't write anything in the drop.
Nice. Thank you, everyone. That was, I missed that. Thanks for the help. Yeah, so drop an A. I only had drop. So if you do drop an A and you print it, drop an A basically drops any rows. If a row has, in this case, 14 columns, if there is one NA in one of those columns in that row, it drops it. So then we end up with 3,695 rows when we do that. Also here, I do want to select only the variables that I will give K-means. And this is what I'm going to tell you next is my personal preference. This can be something that you can decide on your own when you're doing your own analysis. We could give all these data, all these columns to K-means because they're all numerical at this point. Except for, I mean, photo actually is numerical, but I want to remove that. However, I only want to give K-means the variables that make sense for it to create a cluster that is not considering yield data yet. So if you think of it, there are different ways of doing this, right? You can give as many variables as you wish to a clustering algorithm that will change your result most likely. What I'm proposing next is that we only give the variables that are not related to yield, because then once we create these clusters, we can use the yield data to validate the clusters in a way that is unbiased. So we see how well these terrain and EC properties are in the end related to yield without letting them mix when creating those groups. So that's what I want to do next here. So if you add a pipe, I want to do a dplyr select. I do want to keep only the variables that start in elevation underscore meter going through ECA 90. To do that, because they are like sequential, I want all the variables, or maybe almost all those variables. I'm going to say inside select, I say the starting column, I give a colon, and I say the ending column. So ECA 90. So this basically tells select to select all the columns in between elevation and ECA 90. So now we only kept elevation, slope, aspect, full direction, ECA, shallow and deep, and geometry. I do want to remove a couple of columns here. So one is going to be flow direction, because we already talked about it not quite being, you know, it is numerical at this point, but it could have been categorical, and that's probably a better way of or showing that variable anyways. So I do want to, well, I just add a pipe, but I'm sorry, just delete the pipe if you add it as well. We can just come back inside of the select here, add a comma after ECA 90 DSM. I want to break the code just to make it easier to see. And I just want to remove flow direction by saying minus flow there. Right, so if we do this, it's still going to select all those variables until here. And why is that? Don't know. Okay. So if we run that and we printed, it did select all the variables that we asked, and this is selected out full direction. I also want to select out aspect at this point. The main reason for this is because I think aspect is also a little bit more difficult for us to interpret the effect of that on yield overall. So I think I really only want to keep elevation and slope from the terrain variables moving forward on this exercise, because we can more easily understand their effect, both on the cluster, but also on the yield afterwards that relates to the cluster. So please go ahead and do this. So we're selecting all the field variables, I guess how I've been referring to them, and then removing our flow direction aspect out of that. So if you run this and you print it, you should end up with a data set that has 3,695 rows and 5 columns only. And at this point, geometry is still here, which we're going to have to handle that when we do run k-means, but for now we can just leave it there. All right. Okay, so let's talk a little bit about defining k, right? So one of the things I told you earlier is k-means needs us to tell the algorithm how many groups we wanted to look for. Now, how do we define that? So if I tell you that I have a producer that wants to do management zones, and I tell you how many zones do you think that she should have? I mean, I don't know, right? I mean, just like that, there's really no way that you can know. So we're gonna use, we're gonna try out a few things here and see what's the best number of k for this exercise. So to begin with, I do want you to come in the next chunk here, and we're going to run k-means. Let's start with 4 clusters, so 4 management zones for this field, right? So if you go to the next chunk, the function that we use to run k-means is very intuitive. It's called k-means. The way it works is the first argument you give it is the data. So it's going to be the data that we just wrangled above, so all vn. It has a couple of algorithms here. So one of them is called centers. Centers is basically k, is how many groups you wanted to look for. In this case, let's just begin with 4, like completely non-informed guess. Let's just try 4. Another argument I want to change is the argument n start. I do want to say n start equals 10. So before we run this and we look into the results, I just want to tell you, so data, all VN is data, centers is how many groups we want to look for, and n start equals 10. What does that mean? So n start is basically telling how many times I want this algorithm to run from beginning to end and give me the average result. Why is that important? As I already mentioned to you, k-mean, the first step of k-means is random, right? It chooses, let's say in this case that we have centers equal 4, it's going to choose 4 random observations to be the initial seeds of the clusters. And then it's going to iterate after that. If you only run n start equals 1, and it happens that you have your random first step, those seeds placed in one specific side of your data, if you think of like a 2-dimensional data, if it would be all 3 seeds in the corner of it, it may be more difficult for k-means to get to the correct solution in the end. So n start equals 10 is telling the algorithm to run 10 times from beginning to end and give me the most common or maybe the average solution out of those 10 runs. And that just helps the algorithm to not get stuck in one solution that perhaps was wrong because of the random assignment of the first step and give you a wrong solution. So that's what n start is doing for us here. Okay, so if we run that, we get an error. And the error is not very informative, unfortunately, but I do know what's going on. If we check our data, all VN, it has 5 columns, double, 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 double. Everything is double except geometry. So it's not running because geometry is, the geometry column, k-means doesn't know how to handle that. It does not handle geospatial data. So we could have handled that issue up here. I didn't do that because at some point we're gonna need that geometry column in there. So one way to fix that without implementing the fix in the data itself, but just having that on the go here for k-means only, is to add a pipe here. I'm gonna break code a few times just so we can see better. And then we're gonna use a function called st_drop_geometry. If I only run this piece of the code here, all VN pipe st drop geometry, if I only run that, this is what I end up with. It's the same data, except that now it's not a geospatial data anymore, it's just a data frame, and it doesn't have the geometry column anymore. So this is basically what's coming into k-means as the data. And then now if we run it, it should work. So it runs pretty fast. It's pretty efficient in running, at least for our data set. And if you print that object, this is what it gives us as a result. It tells us that it created 4 clusters, and it was 4 clusters because we told it to do that, right? So this centers equals 4. It's telling us what is the number of observations within our total data set that fell within each one of those clusters. It gives us the final cluster means for each one of the variables. So cluster 1 has an elevation mean of 47, a slope mean of 1.68, ECA mean of 3.4, ECA deep 6.6. And it gives us the mean of each cluster for each variable, right? Because if you think of it, in our example that we were doing in the beginning with the theory, we only had 2 variables, 2 dimensions, 2 columns in the data, right? In our case, we have 4. So that's why we have an average of, for each cluster, an average of, for each one of those columns. And then it also creates us, based on the final average of those clusters, using that and the distance of that center to each one of the data points, it can actually give us the membership of the observations. So for each observation or data set, it has a membership that is either, that's going to be one of the 4 values, 1, 2, 3, 4, right? So a given observation can only be member of one of the clusters, right? So we do have one, like here we see that for some of the initial observations in this data. So the row on top is the row number, right? So 1, 2, 3, 12, 13, and so on. And then the row right below it is the membership. So we see that what is the membership of these first rows of the data? This is it.
Dr. Masters,
Yes.
so why did we decided to go with 4 groups?
That's a great question. And it was just arbitrary, right? It's the next steps we're gonna be doing here in this exercise, maybe not today, just because we only have 10 more minutes, is going to be how to use the data and let the data tell you what is the most appropriate number of clusters. We're starting with 4 just to try one number out, but it doesn't mean that we have 4, that we will end up with 4 in the end. Okay, so I guess I just want to go through a little bit more here before we wrap up for today. So I kept scrolling down here, and another piece of information that we get in the end here is the within cluster sum of squares by cluster. I know that this, if you're not familiar with sum of the squares, if you have not had that in a stats course, don't worry. I just want to tell you what is going on here. So for each one of the clusters, in this case, for each one of the 4 clusters, what it's doing is calculating the between cluster sum of the squares. So you can imagine like the error pretty much between clusters and divided that by the total error or the total sum of the squares. And it's given us a proportion. So the way that we interpret this proportion is that the higher this number is, the more the better that is. It just means that more of the variability in the data is being explained by cluster than across clusters. So we don't want a lot of error, like from one cluster to the other. We want the points to be very concisely have a membership of one cluster, and those clusters being very well separated. If they start getting mixed, then this value here lowers, right? And it can kind of go back to this figure here. So this data set probably has a very high between divided by total sum of the squares percentage. These ones probably have a very low one, right? So that's kind of the intuition behind that number, is we want the higher number, the better, right? So right here, let's see. Well, I have some text that we can actually change. But so with k equals 4, which is what we just did, our between divided by total sum of the squares is actually 67.3. So I just want to write that down, 67.3%. Okay, now how does this change if we change k, right? So let's make one attempt here. Let's go back to the code that we just did, the k-means, and change centers. Instead of having 4, let's do 3. Right, so if we run that, it also runs pretty fast. If we print it, now we only have 3 clusters because that's what we asked it to do. And if we just scroll down to the bottom, we see that with 3 clusters, the ratio of between and total sum of the squares is now 60.2. So it basically went down, right? So 60.2%. That's our, and again, the greater this value, the better, if you're just thinking in general terms. Okay, so if we had 4, we had higher number. If we decrease to 3, we lower the number. What would happen if we just increase that number instead? So let's go to another extreme. Let's use k equals 10 and see what happens. So I'm gonna go back to the code again. Change centers, instead of 3, have 10. So now we have 10 clusters. I'm going to run that and print it. So now we see that it gives us 10 clusters with the mean of each column or of each explanatory variable for each one of the clusters. And if I just scroll down to the bottom, now our between divided by total is 81.1%. So I just want to write that down. I just saw that right there. I want to write that down here below on these comments so I keep track. 81.1%. Okay, so if I do tell you that the greater this number, the better, then maybe let's use 10, right? Maybe that's our solution here. Maybe let's increase this. Let's go even higher than 10 and just use a very high number. That is not the way to go, right? So the thing is that as we increase the number of clusters, this number will always increase by default. That's what happens. It's just allowing the data to be more wiggly, to create more clusters that explain more inside the cluster, because you have more clusters to fit to the shape of the data. However, there is a sweet spot, right? There is a sweet spot that we have enough clusters that do explain the general trends of variability in a field, or maybe in any data. It doesn't have to be geospatial. But if you keep increasing clusters after that point, you do gain a little bit of information, and you do increase your percentage a little bit. But maybe now you're just creating too much detail in that analysis. You know, especially if you think of precision ag, if you go to a field that, if the field is really variable, highly variable, and it would do well with 10 management zones, great, use 10 management zones. However, if it is a field that has some variability, that could go by with only 2 management zones, but you go there and say, hey, use 10 management zones, here's what they are, then you're not doing your best job, right? Because you're creating complexity in a field that doesn't require that level of complexity. And that is just translating to more work, and perhaps, you know, more things that producer is going to have to keep track of to have 10 zones, when maybe they could have had just 2 and gone by the same way, right? So I guess the message here is that, yes, we can keep increasing K in the management zone, the number of management zones, indefinitely, until the total number of observations, right? That would be the maximum if you think of it. But that is not what we're after, right? We're trying to find groups of groups of observations that behave similarly, so we can summarize all those 3,000, almost 4,000 data rows into a couple of groups, and then treat them similarly. So that's kind of the intuition behind here. I think we can stop here for today. Next class, I'm going to show you how do we use the data and let the data tell us how many groups we should use. So we're going to do that for this data frame here, and then explore some ways of finding the best number of K, and then implementing that in our data set, defining the management zones, and so on. And finally, validating them as well. So for today, we can stop here. Before we depart, let me get your attendance. Okay, I just opened the issue. Go ahead and claim your attendance if you're watching live. And I'm gonna look into that issue of the NITR and see like if there is a better way to fix that. And I'll get back to you on that. But if anything else, at least you have the website URL on the script that you can just copy and paste in your browser, and then you can have that figure for your reference. As you're claiming your attendance, feel free to do that, and we're good for today. If anyone has any questions, I'm going to stick around for another couple of minutes.
Dr. Bastos, when will we have our final presentation or final project?
Yeah, so the final project, I'm going to give the instructions and the data after we finish this exercise. The final project is, we're not going to do that in class, so you're going to have to do that on your own, kind of like you did with the mini project. Of course, we can use class time to ask, to address questions if you may have, but I'm not going to give you dedicated class time to do the final project. It will require a lot of work from your side, so you're going to have about a month to complete it. It will require a lot of work from your side. I'm sure you're going to run into, you all are going to run into a lot of coding issues and questions. So you can think of the final project as a harder version of the mini project, where now I'm going to give you pretty much all the layers that we had with this up until this point, but I'm just gonna give you raw data, and I'm gonna ask you to do basically all of these workflow that we did throughout the semester for the final project, and then answer some questions along the way. So that's how it's gonna be. You're gonna have about a month to do that, and we're still gonna continue having class and new content as we progress.
Until the end of April, I presume. Is that so?
Say that again.
Until the end of April, I presume. Is that so?
Yeah,
I mean-
so I mean, as I think I have the deadline to be like the last day of class or something like, or maybe the week before. I have to confirm, but it's going to be at least until the end of April. Yep.
Okay, thank you.
Yeah. Anyone else had a question? All right. Thanks, everyone.